Okay, so the engineering constraints triangle. And this is definitely something that, as real world design engineer, you need to contend with. You don't have infinite budget, infinite resources, infinite time to produce something. You're going to be under constraints. You're going to have a deadline. You better get this design within a week or a month or whatever. You're going to have a budget. With the case of senior projects, you have $500 to complete this test. You don't have $5,000 or $500,000. So you're going to have a budget, you're going to have a time, and you want to produce the highest quality product possible, especially if you want to be competitive and sell your product in the real world. And so time, cost, quality was what I introduced in the last section. And here's just a nice little breakdown that you basically have to pick two out of three. You can never fall in this mythical realm in the center. It doesn't exist. If you do it quickly and at low cost, it's going to have low quality. If you do it fast and good, it's going to be expensive. If you do it cheap and high quality, it's going to be low priority, and it's going to take a long time to really find the best way to do it cheap and high. You're going to have to do a lot of research. So there's always a trade-off. Now I have a few great examples here. So I'm not going to go through them all. You could read through this on your own actually and ponder them all. But really, I think the first one kind of nails down the general trend that you need to hang a shelf in your house. And I start out with an example just like this because it's something relatable, right? If you're an engineering student right now, you're probably saying to yourself, Dr. B, I've never worked in a company, or maybe I'm just an intern in a company. I don't know what the design engineers really contend with. Okay, but have you ever tried to, build something at home? Like this, or pick dinner. I don't even know if this one's on the list, but okay, let's start with picking dinner. Do you want to go to McDonald's, right? It's cheap, it's quick, but man, the quality may be a little to question. Or do you want to make something yourself at home, right? So you could probably buy the ingredients cheap, and you could make a high quality product if you take your time, but it's going to take you a while. It may take you an hour to make dinner. Or what's the last option? You go to nice high end restaurants. The quality is going to be fantastic. You're not going to have to wait that long, right? Someone else is making the food for you, but you're going to pay the money. So there we go. So you don't even have to be in an engineering realm to really apply this engineering constraints triangle. Or how about a more of an engineering task, which again kind of goes in line with my dinner one, but maybe more something tangible that you're going to have as a product. And this can be applied even as at a company, for any product really. You need to hang a shelf in your house. You could nail a piece of wood to the wall, so it's quick, it's cheap, but it might not look that good. Or you can buy a fancy shelf, so it's going to be high quality, and it's going to be pretty cheap or pretty quick because it's already assembled for you, for the most part. But you're going to have to pay money for it. Or you can make it yourself. So you could spend the time with the raw materials and make, cut down the wood and sand it and paint it or stain it. And so it's going to be kind of cheap if you made it just from cheap materials. And if you know what you're doing, again, it's going to be high quality, but it's going to cost you time. You may spend a whole weekend on making your own shelf. So, and this, you can kind of apply this to you're working for a company. Do you buy a product that's already available, or do you make it in-house? So these are all conversations you're going to have with your boss and the rest of your team to see, okay, what is the best solution, weighing all three of these options. And really, there is no right answer. I'm not going to say there's a magic formula to get the perfect answer. There really isn't. All right, so usually the best solution is to pick two out of three. And here's a couple examples. And again, I encourage you to, I've provided these notes so you could print it out, read through them at your leisure. So the good solution is to pick two out of three, but of course it's always possible to only optimize one. So, I want the best product. I don't care how long it takes me to find it, and I don't care how much I have to spend on it. That's, or this is something I saw in Mythbusters I thought was pretty fascinating. It's called hypermiling. So when you're driving your car, the goal is to drive exclusively to lower cost while ignoring time and quality completely. So you never drive over 45 miles per hour. You don't use air conditioning. You keep your windows up to reduce drag. You basically make your driving experience very uncomfortable, and it takes a long time to get there, especially if you have an option of driving on the interstate at 65 instead. But hey, you didn't spend a lot of money on gas. So that's always a possibility. You don't have to pick 2 out of 3. Probably most people in their day-to-day commute to work, they inherently try to optimize 2 out of 3. You want to pick, or actually maybe a better example for that would be the third solution, is not to optimize any particular variable, but to compromise on all 3. So let's say you're you're driving to work. You want to pick a good route that's not too long, that you could get there pretty quick, but you don't want to spend a lot of money. Maybe if you have an option of spending money on tolls or another public road, and there's similar time, or even a few minutes extra. Oh, I'll take 81 instead of the turnpike. I'll save a couple bucks. So but so you're kind of like compromise. You're kind of falling somewhere in the middle, this little mythical thing, but you aren't getting the quickest. You're not getting the lowest cost. You're not getting the highest quality. So you're sort of doing in the middle. Or maybe a better example to end this section on, with the compromise would be, okay, what do we do for dinner? I said McDonald's. I said the fancy restaurant. I said cooking at home. What if you go like a fast casual place? Like I don't have stock in these companies, but I'll plug them. Let's say Panera Bread or Moe's or Chipotle or something like that, where okay, it's a little more expensive than the fast food, and it's less expensive than your traditional sit-down meal because you don't have to give waitress a tip and whatnot. But it's pretty high quality food, and it's pretty quick, and you're not spending a lot of money. So you're kind of somewhere in the middle. All right, so hopefully that was a great discussion. Hopefully you could see how you could understand it from your real world experience, but then apply it to the engineering workforce.